Hello, my name is Daniel Soffner. I'm a Senior Success Architect for Salesforce Data Cloud based in Melbourne, Australia. And in this demo, I would like to show how customers can connect Salesforce Data Cloud with external machine learning models, for example, deployed in Amazon SageMaker, how they can use data in Data Cloud to train those machine learning models, and then call the model from within Salesforce Data Cloud. Let's look at the use case first. Let's imagine a clothing company specializing in winter gear. What they want to achieve is develop a comprehensive customer profile for valuable insights and effective personalized marketing efforts. They also want to tailor marketing promotions that are solely based on the behaviors and interests of their customers, thereby increasing conversion rates, overall customer satisfaction, especially for those high value customers that are purchasing a lot of clothing. Now, what we need first, of course, is historical data that show what the customers of NTO have purchased in the past. So what we are collecting in Salesforce Data Cloud are customer demographic details such as location, gender, age range, CSAT, NPS score, and loyalty status. We also collect case information related to previous purchases. For example, the number of cases raised and whether any cases were escalated. We're collecting purchase history, encompassing details about the products that were bought and when they were bought. And finally, we're collecting website and engagement data, including the number of website visits, clicks, and engagement scores. Here's an example or a snapshot of the input training data that have been collected in Salesforce Data Cloud, and that will then be used to train a product recommendation model that is sitting in Amazon SageMaker. In total, we will have about 1 million records that show these past purchases. And what we want to do is build a product recommendation model in Amazon SageMaker that allows us to send data for one particular user, a new user or new buyer, to the model and then get a product recommendation for a piece of clothing. What the overall architecture looks like is displayed here in this diagram. So we have on the left-hand side Salesforce Data Cloud. As you can see here at the bottom, we're collecting all the data from different data sources and storing them in Salesforce Data Cloud. That will be our product recommendation input. In the first step, what we will do is import the data from Data Cloud into Amazon SageMaker Studio via an Amazon Data Wrangler. In the second step, we will build, train, and deploy a machine learning model in Amazon SageMaker that is using the data from Data Cloud as an input. Once that model has been deployed, it will be available as an Amazon SageMaker endpoint and exposed externally via an API in the Amazon API gateway. That is all happening here on the right-hand side within a customer's AWS account. Now, once we have that API, we can invoke it. We can invoke that inference endpoint from a variety of clients. What we will demonstrate is how to invoke this inference endpoint from Einstein Studio, which is part of Salesforce Data Cloud. And after we've invoked that endpoint, we then get a product recommendation output, namely a recommendation what product would be suitable for that particular customer. In a first step, let's look at Salesforce Data Cloud and inspect the data that form the product recommendation input. Here is the data lake object in Salesforce Data Cloud that shows the input data going into training the machine learning model. It contains data points such as the number of cases, number of clicks, whether the buyer is a club member, the date and time when the product was purchased, the state that that person lives in, etc., etc. Here is a couple of examples of data that are going into the machine learning model. In total, we have about 1 million records in this data lake object that will be used to train the machine learning model. In the next step, we will now take these data and import them from Data Cloud into Amazon SageMaker Studio via an Amazon Data Wrangler. We are now in the Amazon SageMaker Studio Classic interface, and the first step is to create a new project. To make things easier, we are using one of the SageMaker project templates that have been optimized for Salesforce. It's the first one in the list. We select the project template. We provide it with the name, product recommendation NTO. We use the same name for the source model package group name, which we will need later. And we also need to provide the name of a secret, which we have created earlier. Now we have created our new project. The next step is to clone the repository locally. In the next step, we will now create a new data wrangler flow, which will connect our Amazon SageMaker instance with Data Cloud. When you click on Import Data, you will have different types of connections out of the box. As you can see here, you can import tabular data, image data from different platforms on AWS, but also from Salesforce Data Cloud and many other systems. Now here I connected to my Salesforce Data Cloud instance earlier, and I can use this connection to connect to my instance in Salesforce Data Cloud. I will rename the flow to product recommendations flow. And here you can see all of the different assets that are running in Salesforce Data Cloud, all of the data lake objects, the data model objects are also calculated inside. And I can now import the data that I need into Amazon SageMaker. I will do this by running a SQL query that selects all of the details that I need to train the model from my product recommendations DLL. That includes details about the purchased product, whether they're a club member, part of a campaign, the state they live in, the month they purchased it, etc., etc. I will run the query and will get the results of that query from the live connection in Salesforce Data Cloud. In order to work with it in Amazon SageMaker, however, I will have to create a data set. I click on the Create Dataset button down here. And what it does, it takes these data from Salesforce Data Cloud that we just imported and creates a data set that we can then use to massage and to work on to do a couple of more steps before we train the actual machine learning model. After creating the data set, you will see that Amazon SageMaker will automatically populate two important steps. For example, the data source and the specification of the data types. What I will do in a couple of subsequent steps is to add new steps to it that define how to drop or handle missing data in the data set, whether to drop certain columns that we don't need for training the model, doing some custom transformation, etc., to get the data ready to train the machine learning model. I have now added all of these additional steps, and our data set is now ready to train the machine learning model. Part of the project that we created in Amazon SageMaker is a notebook that contains the Python code used to train the machine learning model. This process normally takes about 20 to 30 minutes. You would have to go through each individual step and make sure that it's properly completed. But what the code in this notebook does is, in a first step, pre-process the data using the flow file. Then in a second step, build the model using the pre-processed data. And in a final step, register the model in the model registry. After running through the notebook to train the model, we can now switch over to the model registry in SageMaker. And here we see the newly created product recommendation model. When we click on it, we see that we have version 1 of the model, and it is pending manual approval to say, yes, this is the model that we want to deploy. We can go here to Actions and update the status to either approved or rejected. In this case, we want to approve the model. Let us quickly recap what we've done. We imported the data from Data Cloud via the Amazon Data Wrangler into Amazon SageMaker Studio. We then built and trained the machine learning model. If you remember, that was the notebook with the Python code. So the next step now is to create that endpoint and an API to be able to actually invoke and call the inference model. The deployment of the inference endpoint and the API is actually triggered automatically once we approve the model. So when the model is approved, a pipeline is executed in the code pipeline tool in AWS, and that will build and deploy the artifacts that we need for calling the API and the endpoint. So we'll have to wait until that process is finished. After the pipeline has successfully been executed, we can now go to the Amazon SageMaker landing page, scroll down to Inference and Endpoints, and now we will see here the SageMaker endpoint for inference that contains the Data Wrangler pre-processing steps and the trained model. Now, the endpoint, of course, is not exposed externally to the public. Therefore, the pipeline also created an API that exposes that SageMaker endpoint as a public-facing REST API. We now need to secure that API. So, for example, we can create a usage plan. I have a usage plan here already with a request rate of 10 per second, a burst of 10, and a quota of 100 calls per day. we do need also an API key that is required to call the endpoint. We need to add the API key to the usage plan, which we've done here. And in the usage plan, we now have to add the API and the corresponding stage. You can do that here. We select the API. That is the API that was just created through the pipeline. And it only has one stage, stage of prod. We add this to the usage plan. Final step is now to take note of the invoke URL. That is the URL that points to the API and that allows us to call the inference endpoint in SageMaker. We can use this now in a variety of tools to create product recommendations for particular users. Let's go back to our diagram and check where we are. We now have created the SageMaker endpoint and the API and are now in a position to call the inference endpoint to get product recommendations. We will do this in Einstein Studio, which is part of our Salesforce Data Cloud environment. We are now back in our Salesforce Data Cloud interface, and we select Einstein Studio to connect Data Cloud to our inference model in SageMaker. The beauty of bring your own model means that, yes, you can create a model from the scratch in Data Cloud, but you can also connect to an existing machine learning model. As of the creation of this video, which is in March 2024, we have three options: Amazon SageMaker, Google Cloud Vertex AI, or Databricks. So for this video, we select the Amazon SageMaker model option. We are presented with an interface to access the model inferences. The first item we have to specify is the name of the endpoint. Then we have to specify the URL. Keep in mind that is the URL of the API that we just created earlier through the pipeline that we got from the AWS interface. Authentication will be key-based. Authentication header is XAPI key. And here we specify the secret key that we created when creating the API in AWS. The next configuration here is the request and the response format. So essentially, when sending a request to the inference model, it needs to have a certain structure. In this case, we select JSON dense, but we also need to specify the response format that will be coming back to Einstein Studio. In this case, that is JSON. So we leave the default values here. The next point now is the schema for the input and the output, right? So input variables, these are the data that we're sending to the inference model, and output is the schema that we expect back. The variables that go as input into our inference model are the same variables that we also use to train our model in the first place with the data coming from Data Cloud. Now, what's interesting, what we still need to configure is the output. The output will only be one variable, and that is the product interest prediction. That is the product that we are recommending to a person that has the data that we see up here as inputs. The output type will be text, and as the JSON key, we provide then the JSON key that will be stored in the corresponding object in Data Cloud. Let's save this click on next, we now have our summary that we can review and that we can save. First of all, we have to provide a name for our model. Let's call it the product interest prediction model. The model is now saved in Data Cloud. Before we can use it, however, we need to activate it. Now, before we can use the model, we have to switch over to the Usage tab and create a new prediction job. We have to specify the data space where our data reside, and I have to confirm the object that will be used to feed data into the inference model. This is the account contact object. Now I switch over to the account contact details to go through an example. I picked Miss Allison Yates with all of the details and data for her standard object. But when we look at the details here, you will see that we now have also augmented that standard object with fields that are relevant for our machine learning models, such as campaign, the number of cases, number of clicks, whether she's a club member or not, what's her engagement score, etc., etc. So what we will do is we will feed all of the instances of the account contact object, about 100 that we have, into the machine learning model, and we will get a product recommendation for each of the account contacts that we have in Salesforce. I will show that in a minute. So we have confirmed the selection here, the account contact. Now on the next step, we have to map the fields, right? On the left-hand side, we have the model schema that we configured earlier. And on the right-hand side, we can now start mapping the fields from the account contact object to the corresponding field in the model schema. Now, after we've mapped all of the fields to the different variables, we click on next. We now have to specify how the prediction scores are updated. In this case, we want to select streaming. So the prediction scores will be updated as data on our variables change. And we want to include all fields in our prediction. We get a summary here. We have to provide a name for our prediction. Let's call it product interest prediction scoring. And now in the final step, we now need to activate our new prediction job so that it can successfully come up with a prediction for our data. Now we're at the final step of our demo. When we click on usage, we can see now that the prediction job has run. So it means that Einstein Studio has invoked the inference endpoint in Amazon SageMaker, has sent all of our 100 account contacts there with the input data, and has received a product recommendation as an output for each of the different account contacts. As you can see here, when we go to data model objects, we now have an instant of that new data model object that gives us the product interest prediction output. That's what we're interested in. That's what NTO is interested in. And that is linked to a primary object, primary key, which is essentially the ID for our account objects. So that would be, in this case, Miss Allison Yates. We inputted all of her data into the machine learning model and hopefully now get a product recommendation. First of all, what we can do here is, the way to look at this is we look in Data Cloud at our contact data lake object that has all of the sort of 100 account contacts that we have in Salesforce. We found Miss Allison Yates in here. We take her contact ID, and then what we do is also in the Data Explorer, we open the data model object that represents our product interest prediction. We create a filter and we feed the value into that filter. So that is Miss Allison Yates. And we do get a product interest prediction output, meaning that based on Allison's input data and based on the millions of records that we have in Data Cloud on which the machine learning model in SageMaker was trained, we come with the recommendation that a women's Arctic parka would be the most interesting product for Miss Allison Yates. Now, last step here, I'm gonna remove all of the filters, and as you can see here, we get a product interest prediction for all of our contacts that we have in Salesforce based on the input data. And as you can see here, different input data yield a different output. So we've got different product interest predictions for all of our account contacts in Salesforce. In concluding the demo, let's have one final look at our diagram and recap what we did. We started at the bottom by getting the data in Data Cloud to train a machine learning model in Amazon SageMaker, deploying an inference endpoint on AWS SageMaker as well, and exposing it to the public through an externally facing API that we secure through policies and that we can access through an API key. We then configured, that's the upper left part of this diagram, Einstein Studio. We essentially registered our Amazon SageMaker endpoint, provided the input and output data that we're expecting, and then fed all the account contacts that we have in our Salesforce environment into the SageMaker model and got a product recommendation output for each individual account contact. Thank you very much for watching this demo.